We all use engineering products in our everyday, but what we don't know is the role mathematics plays in designing these materials. We talked to Thokhozani Majozi, who's a chemical engineer, to understand and explain us to the role of mathematics in designing these materials. Thank you, Prof. Majozi.
Thank you very much.
In your view, Prof, I would like to know, can there be engineering without mathematics?
No, there cannot be engineering without mathematics, because by definition, engineering is applied mathematics.
Oh.
By definition.
By definition, is engineering is applied mathematics.
Yes.
To briefly explain that.
Let me just explain what I mean. There are 3 steps in engineering. The first step is observation of the phenomena.
Okay.
You know, observation how the nature behaves. The second step is modeling that mathematically, and the third step is solving the resultant mathematical model.
Okay.
So you can see there's maths involved throughout that. So engineering, by definition, you can call it applied mathematics if you don't want to use the word engineering. So there cannot be engineering without mathematics.
Okay.
Yes.
Okay. While you're not a mathematician, because yes, we can't call you a mathematician.
Yes.
There's a lot of mathematics you use in your research. What kind of mathematics do you use in your research?
Okay, yeah, that's a very good question, because mathematics is very broad. The mathematics that I use in my research could easily be categorized as optimization. You know, within the mathematical environment, you have optimization, which is a well-established area and arguably one of the oldest areas. Calculus, for example, plays a very big role in optimization. Because with optimization, that's where we test for what you call the first and second order conditions, where we look at the behavior of the gradient of a function, which is basically calculus. So we use a lot of calculus in optimization. So that's the area that I'm working on.
Okay, still on that, the level of mathematics, how is the level of, what level of mathematics do you need to have to be an engineer?
Okay, you must have studied mathematics to at least third year university level. Okay. So at the final year level, which is our 4th year, it tends to be optional. Okay. But you should have covered it to mathematics 3. Okay. We do have options that will go further even at the final year level. Like I remember in my time, I did the advanced partial differential equation, which was just an option at the final year level. But every engineer must have studied mathematics to a third year level at the university. Okay.
In your own perception, when you're still in high school and now that you are a professor and then you have a PhD, what has changed in mathematics, the use of mathematics? Do you see any change in the use of mathematics when you're still in high school and now that you're
yeah, okay, that's also a good thing. The question perhaps is mathematics evolving in time? In terms of content, I get a feeling that we've converged. Okay. In terms of content. Yes. The things that are changing now are methods of teaching mathematics. I know that during my time we had different methods which never focused a lot on making sure that we understood, but focused a lot in just giving us the information and testing whether we can replicate what we had studied. But we find that now teachers tend to focus a lot on the mathematics, on the teaching methods of mathematics to make sure that the student understands. Maybe there has been a change around that. But in terms of content, it's still the same thing. Okay, but
what about when you're in high school? Did you, now you apply your maths that you used to learn in high school. In high school, or how do you, did you think that you can apply this maths now?
Yeah, okay, I understand what you say, what you're asking. No, I never thought so. In fact, I could not, that's where perhaps I think there might be a change. Our teachers never allowed us, or at least afforded us an opportunity to relate practice to theory. What we learned in class against what you experience in practice, we never got that opportunity. So I never had that practical experience, except to some extent. You know, I think it ranges from grade 10 to grade 12. You've got a section in mathematics which deals with word problems. Okay. So word problems tend to be taken from practical experiences, like so and so is twice the age of so and so. 5 years ago, the difference was so and age. So calculate their ages. You get what I'm trying to say? So in that sense, we could relate it, but it was very theoretical at that time. The only time I really came to grips with how mathematics can be applied in practice, to tell you the honest truth, was when I became an engineer, practicing engineer.
Okay.
Because even at university, they tend to be very focused on theory with very limited implications to the practical side. It's only really when you finish that you can bridge that gap.
Okay, back to chemical engineering. How can South Africa conserve water using through energy conservation?
Yes.
And where does mathematics fit in that?
Yes, that's my area actually. I'm working.
Yes, I know that you've written articles about water
conservation through energy conservation. Yes. You know, the question that you are asking comes at the right time. South Africa is now at a time when we have to revisit our attitude towards water. We have to rethink the way we use energy. We are at that point, and maybe we are a bit late in doing that.
Do you think so?
Possibly, yes. So where mathematics plays a role in my case, you must remember that most of the effluent or emissions, for that matter, that tend to be adversely affecting our environment tend to be coming from industry. So our industrial sector is the major user of energy. It is also the major user of water. So it then makes sense to start from there when you are exploring ways of optimizing or reducing energy use and optimizing water use. Yes. So the work that I'm doing now has been looking at these operations and asking a question. Instead of generating effluent, or I'm talking about wastewater,
yes,
and treating it after you've generated it, the question that we've been asking has always been, should you have effluent in the first place?
Okay. Wastewater.
Wastewater. Yes. Should you have wastewater in the first place?
Okay.
Could you perhaps look at the process and explore ways and means of recycling and reusing this water before you do away with it and treat it?
Okay.
And in some instances, you should remove the effluent stream altogether. Now, to do that, unfortunately, you can't do it manually. You know what the problems tend to be very complex. I'm talking about plants or chemical processes here that we have over 100 unit operations and more than 1,000 streams. This you cannot do manually. So you need mathematics to model that whole operations and build in all the constraints that define the process and then solve it.
Okay.
That's where mathematics comes in.
Okay, no, I get your point, but I heard you saying that we in South Africa we're too late.
We might be a bit late.
We might be late about
changing the attitude towards the way we use water.
Okay.
And also rethinking the way we use energy.
Okay. Well, there's a perception that people always say that people who are good in mathematics are nerds. Do you also consider yourself as a nerd?
I've heard that story many times, but I've never even taken it seriously.
Why do you
I've never even thought about it seriously. Why? Because nobody has been able to define what a nerd is to me.
Okay.
So until I have a fair understanding of that definition, then I might be in a position to categorize myself. But yes, I can't answer the question in that sense. Yes.
Okay, you can't. Okay. Okay, let's talk about this. You have a PhD in chemical engineering. Looking at South African education system and some general aspect about the South African, do you think it's possible for a young South African to obtain a PhD before the age of 25?
It's possible, yes. It is possible. I'll give you a typical example. I've just had a student who finished the PhD. He was arguably 25 years old, if I'm not mistaken. And the way that happened, it happens the world over. The South African system is slightly different in the sense that you finish your 4-year degree first, your junior degree, then you embark on your master's, which for engineering is 2 years in South Africa, and then you do your PhD, which is 3 years. So if you sum everything together, you must have spent about 9 years at university to get a PhD. So for someone who goes to university at the age of 17, which is arguably at the low end, you add 9 to that, you must be at least 26 to really finish your PhD, assuming nothing goes wrong. But there is also a possibility of converting your master's to a PhD, in which case instead of taking 2 years for your master's and then doing PhD for another 3 years, you could literally maybe short-circuit that to about, say, 4 years, and sometimes 3 years. So you can see now, if you take away that one from 26, you do get 25.
So the students,
so it's possible.
It's possible.
You can do that. If you look at the English education system, I'm not going to talk about the other countries in the United Kingdom, like Wales and Ireland and Scotland. I'm not going to talk about those, but I spent a bit of time in England, and I know very well that in England you can actually move from your BSc degree, which for that matter is 3 years, not even 4 years, to a PhD in 3 years. So you can do your MPhil, which is 1 year, and if you've done well in your MPhil, you can easily convert it to a PhD in another 2 years. So within 6 years of university, instead of 9 years, you can actually get a PhD, which means at the age of 23, assuming you started at the age of 17, you can have a PhD, and it happens.
That's brilliant. Yeah. Okay, last but not least, what advice would you give to young South Africans who want to start chemical engineering but don't like maths?
They don't like maths, but they want to study chemical engineering. The advice I can give is that there are 2 options.
Okay.
Either you find a way of loving mathematics, or simply forget about loving engineering. Because these 2, as I told you, they go hand in hand. Yes. You know, it's like someone who does not want, who loves driving, who would like to drive, but he does not want to find himself inside a car. Do you understand? Yeah, there is a phobia for whatever reason of being inside the car, but they would love to drive. So what's the option? Yeah. There is no option. Either you go with the phobia and get into the driving mode.
Okay, thank you very much for being here.